Hello everybody, today I'm going to explain the LeetCode problem 2375. The problem constructs smaller number from the I string, and in this problem we are given a zero index string where we have a pattern with increasing as well as decreasing positions. And in this string we have certain rules we need to respect. Like for example here, if we have a certain position on which the pattern equals I, then the digits at the two positions separated by the pattern have to be increasing, otherwise they have to be decreasing. And the goal for this problem is to construct a number with n+1 digits in such a way that each digit is used at most once, and we want the smallest such number. And we need to have the number to contain n+1 digits. And here we are given two examples. Like for example, here the pattern is made of 3 i's followed by a d, followed by another I, and then followed by 3 d's. And as you can see, the answer is this number 1, 2, 3, 5, 4, 9, 8, 7, 6. And we are given here the explanation. We also have another example where we have constructed in a similar manner the number 4, 3, 2, 1. Now, in order to solve this problem, there are actually a lot of ways we can approach it, and you will see during this video that I will focus on two solutions which I believe are easiest to find, and they are using patterns which are very easy to develop by yourself as well, be it when you practice for your coding contests or for your interviews, or even when you are taking your interview and you would somehow get this problem or something very similar. And the biggest thing to consider is that in the case of this LeetCode problem, the length of the pattern is at most 8. So we are actually looking at very small numbers, and the numbers can therefore have at most 9 digits. Now, a solution which is very simple to develop would be to actually start with all numbers from, let's say, 100 million and going all the way to the highest number with 9 digits, the 999,999,999. And for each of these numbers, we can take each individual digit, maybe even convert it to a string, and then check in linear time whether the number fits our pattern, which, even though it's a valid solution, it's actually a very slow one, because we would have to go through every single number and we would most likely get a time limit exceeded. But even though the solution is correct, we still haven't used a very important property they described in the problem, which is the fact that the integers have to contain only distinct digits, so no digit can be repeated. And in order to do that, we can actually narrow quite a bit the search algorithm I described earlier. And we can start thinking at permutations. And given that we have the digits from 1 to 9, assuming that we are looking at 9-digit integers, then if we want to arrange them according to one of the permutations of this set, a well-known formula, a well-known pattern is the fact that the number of permutations of length n equals n factorial. And here, because we have 9 digits, 9 factorial is around 360,000. So not a very big number. And because we are not talking about a very big number, we can actually create every single permutation. And when we develop this algorithm, we can have a check function which goes through the string, and for each position from the string, checks if the two digits at the given positions actually respect the pattern. Like for example, if we are given something like 4215. In order for this string to be valid, we would need to have something like 2Ds followed by an I. But it turns out that for this particular string, if we want a length of 4, there is also an even better solution, which is 3214. This number is actually the smallest we can go, given that we are talking about digits from 1 to 9, and we want to start with as early of a digit as possible also. And now that we have created these permutations, now it's very easy to think of a solution which, like I said, uses a method to generate the permutations. Several programming languages have such tools, such as, for example, in C++, there is next permutation. In Python, there is iter tools and other similar features, in probably many other programming languages. And even though it seems at first that this algorithm will be very slow, the number of integers we actually have to check is very small, at most 360,000, and therefore our algorithm will run in a time complexity equal to of n factorial times n, where n is the number of digits we are talking about. And let me show you how I ended up coding this solution. So if you look, you can see that it's a relatively slow solution, but also a very easy one to develop. And as you can see here in this page, here we added all the digits in a vector. I prefer using C++ due to it being the fastest programming language. And I initialize the string to be equal to 0. And then for every candidate for the answer, I check using the letters from the pattern whether there is any violation of the rules from the statement. And if there isn't, because I arranged the digits in increasing order, I can actually return the first such answer, because in C++, the next permutation method returns us the permutations in lexicographical order. So basically every number which is first valid is going to be our final answer. Now, the issue with this algorithm, even though it's a very good one for this problem given the small constraints, is that if the length of the number had to be bigger, then this algorithm would have failed, because the complexity scales up very quickly the bigger the number is. So we can think at many other solutions for this problem. There are some greedy algorithms, there are even stack methods, stack patterns from what I've seen, but I'm going to show you next a method which is very intuitive and also very much in this same type of problems, the same type of patterns, the brute force patterns. So now, earlier on, we have analyzed and observed how creating the permutations is very useful for what we need to do in this problem. But there are actually a lot of things we can do better given this algorithm. And now here, what I've done is to observe that when we have a certain permutation, a certain partial permutation, let's say 1, 3, 5, 6, there are many ways to arrange them. And it turns out that when arranging them, you can actually reduce out a lot of the numbers we are talking about, because at the end of the day, the only thing that we really care about is the lowest such number, the lowest number which has these digits and respects the given pattern so far. Because if we can somehow manage to obtain the lowest number for a given subset, then it will be much easier to actually develop an algorithm. And here I'm going to explain a solution which relies both on still some brute force methods, finding all the subsets, but we will also store what we call a TP on this bit mask. Now, to make a quick recap on what a bit mask is, If you consider the digits that show up, we will sum up the powers of 2 corresponding to these digits, and then this will be the bit mask. Again, a very important pattern which can be used in many other problems. Here this sum would be what? 2 plus 8 plus 32 plus 64, which is gonna be equal 96 plus 10, 106. So again, these bit masks are now very useful because we will narrow down this search from 9 factorial to 2 to the power of 9, which is equal to 512. And you can see that this number is much smaller than the 360,000 cases we had to deal with. And now the only thing we have to do is when we are given such a mask, we already know how many bits are set. And when we know how many bits are set, we also know what digits we can continue our pattern with. And we also know the position in the pattern string we need to be careful about. And because of this reason, now all we have to do is to initialize the DPs, as I will show you a bit later, with very large values, and then check out every single possible mask. There are only 512 of them. And then the transition will only go from a mask to another mask which contains the same bit. And let me show you this other solution. And I have here dp of I initialize everything to large numbers. And then for every mask, I first count how many bits have been set. This can be done also within built functions. Many languages have them. And then here, if we are at the end, if the counter is n plus 1, I just convert the number to a string. I didn't want to write any function to do that. And then I updated the answer as needed. And then for every subsequent digit, if the digit is already present in the mask, then we don't do anything. If it's the first digit, I initialize the mask. And otherwise, I check the pattern. If the pattern respects the relation between the last digit and the current digit, I update this DP value. Now, this DP, if we want to be truly rigorous and to be truly sure that it works for other similar problems, a technique often found in problems like this, in bitmask problems, is to add another dimension which tells us the last bit we used, because that would give us a bit more of a certainty that the answer will truly be the correct one. But in the case of this problem, this wasn't required. I got accepted without having to add this condition, and you can see that the runtime is also much better. Again, the problem can be done in other ways. It can be done even with greedy algorithms, even with stack methods, but I presented here what I think is a really intuitive method which uses brute force algorithms and in general brute force patterns such as permutations, subsets, bit masks, and some really simple dynamic programming algorithms. If you found the explanation useful and if you like this video, please like the video, subscribe to the channel, and press the ring button in order to see all of my notifications whenever I upload videos, be it from LeetCode, Codeforces, USACO, or other competitions. And if you have any sort of feedback or comment, please let me know in the chat or by contacting me. And last but not least, if you or someone you know wants to work in order to get prepared for interviews with someone who has helped a lot of people get really good big tech jobs in the top companies, check out my links in the descriptions for ways to collaborate with me closely. And until the next time, good luck with your LeetCode journey and see you next time. Cheers.